Hello friends, welcome back to class again today. We want to solve this maths problem we have on the board. This is an exponential function, an interesting question. So let's solve it together. So let's start with this. The first step is to reduce this to a multiple of 2 and 3, right? Because 2 times 3 gives you 6. Now we still have our power 2n plus 3. Then over here, we write this as 3 raised to the power of 2 times the existing power. Then multiplied by, reduce 4 to base 2. So that would be 2 to the power of 2. Multiply the existing power, 2n minus 1. Then let's go to the denominator. Over here, you know that 2 times 3 times 3 will give us 18. We are making an attempt to reduce all the bases to an index of 2 and 3. So to solve further, we'll have 2 times 3 raised to the power of 2. 3 power 2 is 9. 9 times 2, 18, which is the original number we have here. All to the power of n plus 1. The second one remains the same. Nothing changes because it has been simplified already. Then over here, we have 2 times 2 times 3 to give us 12. So we pick 2 power 2 times 3 all to the power of 2n plus 1. So we have taken the first step into the equation by reducing all the bases to an index of 2 and 3. Now to solve further, let's distribute the powers to the terms inside the bracket. Remember that when you have, let's say, a times b all to the power of n, this power can be distributed to the both of them, hence, so long as they have multiplication in between them. So when two numbers multiply themselves, power can be distributed. So this is 2a power n times b power n. So let's apply this to so many of them here. So over here we have 2 to the power of 2n plus 3 times 3 to the power of 2n plus 3. I distributed this power to both 3 and 2 times, this remains the same. Now let's expand the brackets here. We have 2 to the power of 2 times 2n, we have 2n, no 4n. Now 2 times negative 1, negative 2, all over. Let's make the same attempts here, the denominator. So this n plus 1 will be distributed to 2 and 3 power 2. So 2 raised to the power of n plus 1. And then 3 power 2 raised to the power n plus 1. So I'll say times. I can multiply 2 times n, 2n, and 2 times 1, that is 2. This one remains the same. Then over here, we distribute. This multiplies this. So that will be 2 to the power of 2 times 2n is 4n. And then 2 times 1 is 2. Then this to this power times 3 to the power of 2n plus 1. It is getting more interesting. So what else can we do? If you look here, you observe that we have base 3, base 3. And they are alike. Base 2, base 2. They are alike. And one of the laws of indices says that when you have two bases that are equal, they are multiplying themselves. You can add their powers. For an instance, b times b, n, and then m. The bases are equal, but their powers are different. What do? Pick one base, and then you add the powers. Okay? Let's do that here. 2 and 2 are the same base. So I am picking 1, and I'll add their powers. 2n plus 4n, that'll give us 6n. 3 plus minus 2 should give us 1. Then 3, the same. 3 are the bases here. 3 and 3 are the same. So we take 1 and add their powers. 2n plus 2n will give us 4n plus 3. Nothing to add to it. All over this base and this base are the same. So we add their powers. N plus 4n. That will give us, sorry, we have this one also. N plus 4n will give us 6n. Now 1 minus 1, 0, plus 2. That is 2. Then for 3, we have 3 and 3 here. So we take 1, add their powers. 2n plus 2n gives us 4n. Now 2 plus 1 would give us 3. What do you observe? This one here and this one are the same. So we can possibly cancel it out. This and this will cancel out. Let me show you why. If you have, let's say, A times B over, let's say, C times B, you know that B will cancel out B, right? Because this is multiplication and these are like terms. So the like terms have cancelled themselves out, leaving us with 2 to the power of 6n plus 1 all over 2 to the power of 6n plus 2. So what else can we do from here? You know that these powers can be separated to this space using multiplication. One of the laws of indices says that when you have, let's say, a to the power of n plus m, you can split the powers to base of a using multiplication. So a will multiply itself, then split the powers. Here is m, and here is n, and here is m, right? So let's do the same thing here. Consider this as n and here as m. So splitting, we will have 2 to the power of 6n times 2 to the power of 1. Same here. 2 to the power of 6n times 2 to the power of 2, these two. We also have like terms at the numerator and then the denominator. So 2 power 6n, we cancel out 2 power 6n. The reason they are cancelling out is because they are multiplications. So this one is serving as the coefficient to this. This serves as coefficients to this. So they can easily cancel out. Now look at what it looks like. If you have, let's say, 2 to the power of x squared over 2, let's say 2y. Obviously, these two will cancel out these two, right? And when that happens, we now have this and this remaining. So let's continue from there. Bringing down this, we have 2 to the power of 1, which is same as 2, over 2 to the power of 4. 2 to the power of 2 will give us 4. Now, 2 divides itself 1, and 2 divides 4, 2. So the solution to the exponential function is 1 over 2. Thank you so much for watching. Please do well to like this video, share with all your friends, and return for more interesting math tutorials. Do not forget to subscribe to my YouTube channel. Bye.